Okay, now we went through the example, and I thought I'd put this on a separate video. Now for the example problem that we're going to do. Here's my friend over here, and let's see, I go a little bit further. Here's me over there. And let's see, where's my y-axis? I'll say my y-axis is right in the middle. Does that look like it's in the middle? I hope so. And okay, and I know that I'm 4 miles away from my friend. So this distance right here, beautifully demonstrated there. Why can't I do that? Much nicer. Let's see, it's 5,280 times 2, which is 10,560 feet, okay? Same on both sides. We put the origin right in between. That's what our intention was. And then there's this noise that goes off while we're on the phone talking to each other, tied to our landlines, because we're not moving. We're not on cell phones or anything, unless we're just sitting down. And I have 1,100 feet per second. And my friend here is at 18 seconds later. So how many feet is that? Well, I have 1,100 times 18. That's 19,800 and 800 feet per feet, just feet extra. So, let's see here. Let's see if we can make this realistic as possible. We will go something like, what do you think? Does that look like it's about that far? Maybe not much further than 10,000. We'll say that it is, best as to our ability. And then we're going to say the explosion must be the difference between those 2 points. So, and it should be equal to both these points. So I'm trying to think of a triangle, and I'm putting it right here. Maybe that's not great, but my intention was to get these branches to be the same. I was trying to make these the same. I hope maybe they don't look quite the same, but you'll forgive me for not being exactly. Okay, so it's 19,800 feet along here, and then there's some distance where it's the same. And if B were on a tower right here, if my friend were right here on a tower, he would have heard it at the same time, but he's not, and he didn't. Okay, now here's the thing. If I lay this down like we did in the example, if I lay it down in the example, it'll probably go a little further. So now I'll say, if I bring that down here, now we'll say it's 19,800 feet along here, okay? And what's left over? Well, let's see. Remember we said, oh wait, hang on. There's the vertex somewhere in here of a hyperbola, okay? So it has to be right in the middle. Between these 2 points, because I know that on this side I'm going to have C minus A, if you remember the example, and on this side I'm going to have C minus A. Okay, so I know that 19,800 feet plus my 2C minus A. And I tried to explain that best I could up there in the example. If this is C, no wait, where's C? If this is C, and this is A, and I say, this one, this C, minus this A, I'm going to have this little strip of ground right here. Because they're almost the same, so if I subtract them from each other, it's just that little section right there. And it'll be the same on both sides, okay? Because remember, it's supposed to be that if my friend is this far away, now it's flattened down here, and now, it's supposed to be equal between. So if the explosion happened, where A is, then I'd say we'd hear it at the same. We'd hear it the same if my friend moved over to this new location. But he didn't, and he's not. So anyway, that's how we're thinking, anyway. And so we're saying 19,800 feet plus these two little pieces of c minus a should equal the total distance, which is, I don't know, 5,280 times 4, which is 21,120. So that's not leaving me a whole lot of room over here. That's why we call them little segments. So I'm going to subtract the 19,800. And let's see, if I do that, I get 1,320. And do I know c? Yes, I do. So I can say 2 times c. 2 times c. C is 10,560 feet, remember. Minus 2a. Well, two of those, what do I get? I forget. So we say 10,560 times 2, that's 21,000. I'm going to subtract that from both sides. 21,120 feet. But you say, well, I'm going to get a negative. Well, it's okay. I have a negative 2a over there, so the negative's going to go away. So if I subtract that from both sides, I get negative 2a is equal to, and I'm subtracting this 21,120 from 1,320, and I get negative, I probably should have seen this coming, but anyway, there it is. And I divide by negative 2. It's hard for all the trees in the forest to see. And a is equal to, what is it? So, it's divided by, yeah, okay. So, what do we get? 9,900. Okay, so that's my a right there. That's at 9,900. In other words, almost the whole 10,560, as we thought. It must be. There's not much room left. If my friend waited so long to hear it, it's a pretty tight situation. So now they're asking me for, I need to know b if I'm going to write the thing they're asking me for. They're asking me for the equation of the hyperbola. So there is some hyperbola. Let me go ahead and try to draw it the best I can. I'll say it goes something like this. It goes through this point. That point has to be on the hyperbola. And it goes through A. A is the vertex, right? And over here, there's another vertex, over here. I don't care about that vertex. Don't care. I just care about this one on the right. And then, it does this down here. That's fine. It's doing its thing. So anyway, just so you're thinking about the right branch of the hyperbola here. And we'd like to know what b is, so I can say somewhere on that arc of the right branch of the hyperbola. I called it an arc. Maybe I shouldn't have done that because it's not a circle, is it? Okay, so anyway, c squared is equal to a squared plus b squared, and I will say c squared minus a squared is equal to b squared. So what is that? Well, let's see. What's c? I forgot what c is. C is 10,560. 10,560 squared. Oops, wrong key. Oh, wrong key again. 10,560 squared. That's 11 million. It's 11 million. It's a big number. 513. 600,000. Minus a squared. Well, we just found out a was I tried to switch it. That's what I get. Okay. I'm going to square a, 9,900, and I get 98,010,000 and nothing. And that's going to give me b when I subtract, and it's 13 million. B squared is 13,503,600. Okay, I can write my formula. It's going to be great, too. Let's see. I have x squared because I don't need h because I purposely put it at the origin. And what's a? Well, it's 9,900 squared, which we said is 98,010,000. So I'm just going to write it like that. Minus y squared over b squared, which is of this hyperbola is my explosion. And if you had a third person in listening, like you do in your example, you would be able to know exactly where. But at this time, it just says find an equation that provides the possible places. Okay, well, somewhere along that branch, okay, somewhere along that right branch of the hyperbola, anywhere on here fulfills the criteria. We just happened to put it here in our drawing, but anyway, somewhere on that. And according to my, I think I went too far up there, so it's really probably more like down here. I don't know, where you might actually believe that these lines are the same. I don't know. Maybe that made it worse. Okay, I'm sorry. But anyway, it's somewhere on the arc. Okay, so there's your help screen. I plotted the points for you, and I wrote some things down so you could think about the problem.